We have given two curves. First, we will find the intersection points. We have to set the two equations equal, so we will have 1/3 x plus 1 is equal 1 plus square root of x. We have 1 and 1, so this will reduce. So we have 1/3 x is equal square root of x. Now to reduce square root, we will take both sides to second power. So it will be 1/9x square is equal x. So now I will move x to the left side, so we have 1/9x square minus x is equal 0. We can factorize x, so we will have 1/9x minus 1 is equal 0. When x will be 0 or x will be equal 9. So let's check now our solutions. We can calculate square root of 0 and square root of 9, so everything is okay. So next, when we have x coordinate, we can find the y coordinate. For x equals 0, y will be equals, we can put to this equation, will be 1 plus square root of 0 is 0, so we have 1. And for x equals 9, we will have 1 plus square root of 9 is 3, so we have 1 plus 3 is 4. We have 2 points of intersection. Now we will draw xy plane. We have 0 and 1 and 9 and 4, so we have to choose very small unit. First point is 0, 1. For 0 we have value 1. This is our first point, and 9, 4 is the second. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. For 9 we have value 4. 1, 2, 3, 4. So this is our second point of intersection. So now we have to draw our curves. First is 1/3 x plus 1. This is straight line. Coefficient before x is positive, so it means going up. We have 2 points for this curve, so one more we can calculate to see which is up and which is low of our function between this interval from 0 to 9. I will choose 4 because for 4 is very easy to calculate square root. So for 4 we will have 1, 2, 3, 4, value 4. We will have 1/3 times 4 will be 4/3 plus 1, so is 2 and 1/3. This is approximately here because here we have 2. And now we can draw our straight line first. This is y equals 1/3 x plus 1. And the second is 1 plus square root of x. So let's choose the same value for x, 4. So it will be square root of 4 is 2, 2 plus 1 is 3. So we see that the second curve is above our first. We have value 3, 4, 4. And this is our point of intersection. So the second curve must pass this point, and our second curve start from 0 because we cannot calculate square root of negative values. So this is our second curve. This is y equals 1 plus square root of x. Our area between these two curves is this. let me shade this. We see that our area is between interval from 0 to 9. So we will calculate area of our curve by using definite integral from 0 to 9. First, we have to plug function which is upper. Upper is 1 plus square root of x, and we have to subtract the function which is lower. The lower is 1/3 x plus 1. And we have integral with respect to x. This is equal. We can reduce something because we have negative sign, so 1 and 1 will reduce. So we have integral from 0 to 9 of square root of x minus 1/3 of x with respect to x. I will write square root to power form, so we have integral from 0 to 9 of x to power 1/2 minus 1/3 x dx. So this is equal. Integral of x to 1/2 power is x to 3/2 power over 3/2 minus 1/3 we copy, and integral of x is x squared over 2. We have integration limits from 0 to 9. So this is equal. We can flip this fraction in denominator, so it will be 2/3. And we will have x to power 3/2. So this is square root of x to 3rd power minus 1/6 x squared. Now we can plug our limits from 0 to 9. So first I have to plug upper limit, so this is 2/3 times square root of 9 to 3rd power minus 1/6 9 to 2nd power, and we have to subtract the lower limit. But when we substitute x's by zeros, first expression will be 0 and the second 0, so we don't have to do this. So this is equal. We have 2/3. Square root of 9 is 3. 3 to 3rd power is 27. Minus we have 1/6 times 81. So this is equal. We can reduce 3 and 27 is 9. So 2 times 9 is 18. Minus, and we can reduce 6 and 81 by 3. So it will be 2 and 27. So we have 27/2. So this is equal 18 minus 13 and 1/2. So this is equal 4 and 1/2. This is our area, and because this is area, so we have to add square units. This is my solution.